All right, so an absolute value equation is a graph that looks like a V, okay? We've been working with lines, but when you add in an absolute value equation, it turns it into a V, okay? And a translation is a shift of a graph horizontally, vertically, or both. So we can take a graph and move it up, down, left, or right. Now, we're going to be working with this basic graph today called y equals absolute value of x. And this is the very basic absolute value equation. And on this graph, what happens is it's a V that starts at the origin, and it just makes a V going this way and this way. So that's the very basic absolute value function. All equations that we're going to be graphing today are going to be based on this graph right here. We're either going to move this graph up, down, left, or right. Okay? All right, so let's look at example 1. We're going to be comparing this basic graph to the graph of y equals absolute value of x plus 1, and we're going to note the similarities and the differences. All right, so I'm going to highlight the basic graph in red. This is y equals absolute value of x. And then we're going to compare to that one the graph of y equals absolute value of x plus 1. What do you notice?
It went up 1.
Right, the blue graph went up 1. And what do you notice that's on the right side of the absolute value sign?
Plus 1.
It is. So that's what happens. When you add a number after the absolute value, it either takes it up or down. In this case, it was a positive 1, so it takes it up 1. Had it been a negative 7, would have taken it down 7. Okay. So this question asks us to describe the graphs of y equals absolute value of x and y equals absolute value of x plus 1. How are they the same and how are they different? Well, how are they the same?
They have the same slope.
Good. They have the same. That is correct. They have the same slopes. They both are the same shape, right? They have the same slope, same shape. And then their differences is one of them is shifted 1 unit up, okay? One of them is shifted 1 unit up. So that's what happens. The number that comes after the absolute value either tells you to go up or down with your graphs. So now we're going to practice that by graphing one of these equations. Are people still writing?
No.
Good. Okay. All right, so example 2. All right, example 2 is y equals absolute value of x minus 1. It says to graph it by translating the graph y equals absolute value of x. So we're going to move that simple graph that starts at the origin, and we're going to move it either up or down. If it's absolute value of x minus 3, does that mean we're going to move it up or are we going to move it down? Down how many units? 3 units. So we're going to put our point at negative 3. How do we know what is? Well, I'm going to show you. You mentioned slopes earlier. The slope on the right side of the V is at positive 1. So what that means is from this point, we go up 1, right 1 to get our next point. Up 1, right 1. Up 1, right 1. Okay? So this slope this one has a slope of 1. The other side has a slope of negative 1. So that means you go up 1, left 1. So this has a slope negative 1. So that's how you know how to slant your V. You just use those slopes. The right side is a slope of 1. The left side is a slope of negative 1.
Always?
On all of the ones you will be doing today, yes. There are some that don't, but we're not going to cover those cases. So I'll give you a second to go ahead and plot those points.
She writes sometimes really hard.
All right. Now, the next example, we're going to go backwards. We're going to write an equation. Okay, we're going to write an equation for these different shifts. Okay, on example 3, we have a shift of 9 units down. So we're going to write the equation. Okay?
Y
We're gonna-
equals X minus 9.
Is it, yeah. Well, absolute value of X and then minus 9. Yes, this right here says 9 units down. So what we're going to do is we're going to take the graph of Y equals absolute value of X. We're going to subtract 9 from it, and that's how you get your equation there. That's all you have to do on that, yes.
So this is the same thing with plus 13.
Y equals 0 plus 13.
Exactly. On letter B, it's 13 units up. That means we use positive 13. So we take the basic graph Y equals absolute value of X, and we add 13 to it. That'll move it up 3 units.
I'm confused.
So those cover our up and down shifts. Okay, those cover our up and down shifts. Now we're going to talk about our left-right shifts. These are a little different. Okay. If you look at example 4, I want you to notice instead of the number being on the outside of the absolute value, where do you see that number?
Inside.
It's on the inside. All right, so this time, if the number is on the inside of the absolute value, it tells you to go left or right. Outside of absolute value, up or down. And that is something that you need to memorize, okay? If it's outside, then it's up or down. If it's inside, right or left.
Positive, you go right.
Well, and you would think that if it were positive, you'd go right, correct?
Yes.
That's actually the opposite. On a left or right shift, you have to go opposite what the sign intuitively tells you. This says x plus 2.5. So that actually means you're going to go left 2.5. So you just have to remember that your left and right shifts are backwards from the sign, okay? So on this, if it's plus, you go left. So we're going to take the origin and we're going to move it left 2.5 units. So we're going to go left 2.5 units. Here's 1, 2.5. And then go ahead and fill your slopes in. Your 1 on the right and your -1 on the left. Go up 1, right 1. Probably only going to be able to get 3 points in there on the left. And then connect the dots and you got your graph. So it's important that you remember that the left and right shifts, you have to think opposite the sign. So letter B, since it's a negative, which way are we going to go, do you think? We're going to go right. Yes. So if it's negative, you go right. So we're going to need to go right 2.5 units. Fill in your points and then connect your dots. So that's how you do a left or right shift. And it's important to keep them separated, knowing which ones are up and down and which ones go left and right. Okay? It's easy to get them mixed up if you don't study that enough. All right, so let's write some equations for some shifts that go left and right. And just like graphing them, you have to think opposite still. Even when you're writing the equation, you have to think opposite. Because letter A, it says 10 units to to the left. Okay, because it's left, we know it's going to go within inside the absolute value bars, and you have to think a positive number. So your equation looks like this. Y equals the absolute value of x plus 10. So you have to put the number inside the absolute value.
Get it. Real easy.
Letter B says 7 units to the right. We do the same thing, but instead we put a minus sign. So it's y equals the absolute value of x minus 7. We're not done yet. We're going to have an example C that you don't see out in your paper yet. Okay, you're going to have a letter C, okay? I want you to write this equation for a shift that goes 2 units up and 10 units left. So write an equation. You're going to have to incorporate both shifts, okay? You need to shift 2 units up and 10 units left. Write the equation for that. Alright, so you have to incorporate 2 shifts, okay? The 10 units left has to go inside the absolute value. The 2 goes on the outside of the absolute value. So your equation is this. Y equals the absolute value of x plus 10, because you have to go backwards on the sign, and then 2 units up, so plus 2. And that is your equation.
We do our homework there. Wow. Yeah. Yes, because I want to get it done, because I know I'm not going to do it at home.
All right, your assignment is on page 361 to 362, 1 through 27 all.
Oh.